Hello to day 5 of Advent of Code. We are again trying to solve two puzzles and we are again using Kotlin, and I'm wearing this amazing, really amazing Christmas sweater with a tie. Unfortunately, of it is green, and due to the green screen you can't actually see. It looks pretty weird. Today I will be joined again by our awesome Copilot, the GitHub Copilot, which is an AI that will autocomplete whole blocks of code, and we'll see again if it will be helpful today. And we will be using IntelliJ again. So let's look at day 5, and I hope every one of you has some coffee. All right. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines, and the submarine helpfully produces a list of nearby lines of vents, your puzzle input, for you to review, for example. Okay. Start point and end point. Each line of vents is given a line segment in the format starting point to end point, where x1 and y1 are the coordinates of the end of one end, the line segment, and x2, y2 are the coordinates of the other end. These line segments include the points at both ends. In other words, entry like 1, 1, 1, 3 covers points 1, 1, 1, 2 and 1, 3. Entry like 9, 7, 7, 7 covers points 9, 7, 8, 7 and 7, 7. For now, only consider horizontal and vertical lines. Lines where either x1 are x2 or y1 are y2. Okay, that means we do not need to care about diagonal. And since this ASCII example, probably also not half covered or partially or not covered at all points. So the horizontal lines for the above list would produce the following diagram. What is this? 0, 1, 2, 2, 1. Is there 2, 1? Here. Oh, 2, 2, 2, 2, 1. So this one comes. Okay. So at first you think it's from here to here, but it's actually from the bottom to the top. Okay. So they kind of have a direction, but is this important? In this diagram, the top left corner is 0, 0 and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point or a dot. No line covers that point. The top left pair of ones, for example, comes from 2, 2 to 2, 1. Yeah, that's the one we just looked at. The very bottom row is formed by the overlapping lines of 0, 9, 0, 9, 0, 1, 2, 3, 5. That is not 9. Oh, 0, 9, 5, 9. Okay, makes sense. And 0, 9, 2, 9. So that's why those are twos. Two lines on this point, okay? To avoid the most dangerous areas, you need to determine the number of points where at least two lines overlap. Okay, so essentially all the twos in this example. In the example above, this is anywhere in the diagram with a 2 or larger, yeah? A total of 5 points. 1, 2, 3, 4, 5, yes, okay. Consider only horizontal and vertical lines. At how many points do at least two lines overlap? Okay. So again, the question is, what does the input look like? Okay, those are just the points. The question again is, how do we represent the data so that we can process it? kind of like the day before, we could build a 2D structure that holds those, but I don't think that is necessary for part 1. The problem is always you do not know what's coming in part 2. Thing that is interesting is that it says for now only consider horizontal and vertical lines. So maybe in part 2 we need diagonal. We do not know. So how else could we do this? We are only interested in overlapping. The interesting thing is if we have a line like this one, then we have a start point and an end point, and there are points in between. We could try to break that up. If we get a start point and an end point, we try to collect all points. And if we have a list of all lines with all points, not only start and end point, then we only need to find duplicates. And in theory, individual lines do not even matter because we only care about covered points. Like if this point here, for example, it doesn't matter from which line it comes, if it even forms a line, as we only need to know is it 1 or higher. So we could just collect all points, like turn start and end point in a list of points, collect all points, put them all into a list, and then find duplicates in this list. Yeah, either find duplicates or process this list into, reduce it essentially to a count, where we have every point and a count. And then we take only those that have a count higher than 1. Yeah, I think I like that idea. I think reading the data will be easy. Then creating all the points from start and end point, maybe it's a little bit tricky because it doesn't seem to specify that the first one is on the top left and then the bottom right. It seems like sometimes things are coming from the bottom to the top, from left to right, and we need to figure out in which direction we are going to figure out which kind of points to collect. And for now, only consider horizontal lines, and it looks like the data, like if I take this one, this is not horizontal, so maybe we will to do diagonal at some point. But we definitely need to find horizontal and vertical lines first, and this is from that. Okay, I have a rough idea. Let's create a folder. Package day 5. Create a day 5 Kotlin file. And like the last time, function. Part 1 function, part 2 function. Then let's start with executing part 1. Let's do this once just so that it's set up here at the top and we will not run the code of another day. And yeah, Codepilot, as you can see, Copilot, sorry, will, as you can see, try to autocomplete all functions. Will be super confusing at times, and let's see. Let's grab, as always, we still don't have written any helper function. We always need to start from scratch reading the code. So let's start with the read lines function, I guess. And for that we create a structure, and the line has a start and an, but I guess we can make it like in the example x1 and x2 to return a list of, and then get those by mapping over our values. Let's look at the, why didn't we download the data yet? Let's save the data. To IntelliJ, to the root folder, call it day 5. And let's see, we split here, and we turn both into, and we split those two, trim it, turn it into ints. Awesome. So we have a line, we split it by this whole thing, I guess. And then we want see, can we destruct this point 1 and point 2? And oh, this is cool. X1 and Y1 is 0.1 split by comma. Yeah, that is correct. Now where did it go? Yeah, this. The same thing for this. Yeah, awesome. And then we map it to a point with those as ints. And it's not a point, it's actual line. Cool. Let's try this. Just print them. Let's see if this works. Index out of bounds. Let's see, what did we do wrong? Oh, is it because at the end there's an empty line? Just remove it. No, it's not. Okay. Then we do index out of bounds. Which line is this happening? Oh, we are reading day 4. The same old problem. Let's split day 5. Okay, we have 9 from 405 to 405, 945, 7895. Okay, that looks good. Maybe it would have been nice to write tests for all those things, but that's life. No, we are mostly interested in solving the puzzle, and that still seems possible without the tests. So back to this. So for now we only need horizontal and vertical lines. So let's create some helpers. Is horizontal. Oh, nice. Is vertical. Wow. It is exactly exactly what we wanted. Or vertical. And it, yeah. I mean, for this code, GitHub Codepilot is super awesome, I guess. What is it complaining? It could be private. That is probably true. It could be a property too. It doesn't need to be a function, but that is not important for the puzzle. So we read the lines, then we filter only those that are horizontal or vertical. Oops, now we made this private too. That's not what I intended. Okay, now we have only horizontal or vertical line. That is great. And now we need to extract all the points from. Now I'm curious if this is actually able to do get points, and we want a pair of ints. That is our point. If horizontal, return pair x1. I want two pair. That is return pair of x1. And this is even wrong. We want a list of pair of ints, like a list of all points. Now let's see if Codepilot can do this. Okay, it creates a list of points. If it's horizontal, it goes through the list, adds all points. If it's vertical, it adds all points. This is interesting. This only works if it's a line that is from left to right and top to bottom, I think. And this does not seem to be the case. All cases, I think. This one. It is higher on the X and then goes from right to left. So this does not work, unfortunately. How can we do this? Let's take this as an example. That is interesting that it's proposing min. Because if we take the previous example, this one, this would have worked if x1 is always the smaller one. But we can make it so. Let's steal all of that code. Ugh, now it's confusing. Start x is the smaller, and x is the larger one. Should be replaced with Kotlin function. That is probably right. Although I think the min and max was easier to read, but anyhow. Nice how it's auto-completing. Okay. Now we get a list of points. And it might be not that hard to do the same for horizontal. Sorry, diagonal, if this is part 2. But let's see. Those two, their points. And since we do not care about the actual lines, we flatten them. Now we have a list of points. Let's print those. Oh, distinct is interesting. Okay, now we have tons of points. Now we only need to find the duplicates. Let's see what Kotlin offers us. Duplicates. Oh, that what? It just offered us to. Or was this? Oh, this is only Codepilot that offers us to find those, but we could write it ourselves. Codepilot. First we try Codepilot, and otherwise we write it ourselves, which could maybe do with a map that keeps the counts. Get points, but get duplicates. See. Codepilot do it. Creates a mutable set for each point if count it point is bigger one. What is count? For each. And then it edits. What is the count? I don't understand this part. Count. Oh, it counts how often this is. Wait a second, it goes. Oh, and then it counts. Okay, that is super not quick to do. Look, like it goes over each point, and then for each point it counts all the entries in it. Is not great runtime, right? Because for every point we need to go through the whole. Maybe do the map thing. Or we could just run it once and see how it performs before we optimize. Okay, it is super slow, as expected. Okay, let's stop that. Instead, we do exactly what it proposed. A mutable map of every point to its count. Go through all those. Set it to 0 if needed. And add count it and return. Yeah, perfect. We filtered down to where the count is bigger than 1, and then we get the keys, which is the points. Now we need to actually return this. In this case, we only go through the list twice. Go once the list to count in the map, and then we go through the map essentially and take all the ones that have a count larger than 1. This returns a set instead of a list. I can live with that. And let's run this. Okay, done. Let's print the points. Those are our duplicates. Awesome. Let's take a look. What do we actually need to do with them? Determine the number of points where at least 2 lines overlap in the above. For example, this is anywhere in a diagram with a tool. Consider only at how many points do at least 2 lines overlap. Okay, now let's get the size and let's hope we did it right. 7,438. That is a lot. It's true. Awesome. Part 2. I kind of hope it's not diagonal, but let's see. Unfortunately, considering only horizontal and vertical lines does not give you the full picture. You need to also consider diagonal lines. Damn it. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line at exactly 45 degrees. Thank you for that. So we'll be able to always find the points. Considering all lines from there would not produce the following would now produce the following diagram. Okay, we have diagonals. You still need to determine the number of points where at least two lines overlap. The good thing is it is hopefully fairly easy, because the thing we did here, let's copy this into part 2. We run part 2. Here we filter horizontal or vertical lines. We do not need to do this anymore. The only thing we need to do is diagonal. And it says if it's not horizontal or not vertical. That is smart. I was just wondering, should we just compare the points, but we could just use the functions we already have. Awesome. So we need to add a case here now. What do we do if it's diagonal? Let's see. Else if is diagonal. Oh, come on. Okay. So we have a start and an end. Yeah, we need again to normalize the points. If then dx and dy. This is the steps we will go, maybe. So we start at start. If we are not at the end, then we add the current point. Okay. Then we go steps into the direction we need to go. But it's always, I'm confused by it's always being 1 or -1 here, since we already the interesting thing, since it's always perfectly 45 degrees, we can always go 2. So 1 on the x-axis and 1 on the y-axis. This one is deciding in which direction it needs to go, but only beginning, which probably does not make sense. Well, that is not true. We can determine the direction at the beginning, and then we go into this direction, but then we don't need to actually determine the start. Since if we move the start to always be here and the end here, then it's always in the same direction, I think. Let's try this, run this, and then I think we optimize this. But otherwise this looks good. We add the current point and we move. And if it's not the end point, do we ever add the end point? My god, I hate that we are now reviewing, but should we just write this ourselves? It's not the endpoint, but we also want the endpoint. Yeah. Can even be explicit so that you see it. We're doing. This is end x and end y. And now we can just run part 2. And it is in an endless loop, I think. Oh, stop. Yeah, this is actually a bug now. Wait a second. Since we optimized this to start to always be the top left, always be the bottom right, the end, always go +1 on X, +1 on, I think it's always 1. I think it's buggy now because it's calculating the direction, but it's not actually starting at X and Y 1 and 2. It's starting at the fixed points, and then it should break. Let's run it again. Ah, this is working now. See if this is the correct answer. That is not the right answer. Your answer is too high. If you're stuck, make sure you are using the full input data. Oh, if it's should we not have added the end? We need to add the end. Now I'm fishing. Turn to day 5. You gave an answer too recently. You have to wait after submitting an answer before you have 25. Okay. Then let's actually wait. We are. This is so confusing if you do not write it yourself. Why did I trust Codepilot? Let's try this one. That is not, it's too high. It's still too high. Okay, I think we need to look at one example. And let's do this by get null points from start X to end X, or actually start Y to end X to end Y. Get a list of pairs of ins. And this here return get points y1 x2 x2. Okay, this is now super confusing. Maybe move this in, make this return points, this, or return this. Every case is on. And that looks better. Okay. Now let's just implement this function. Here we go again. There's a start point and end point. Oh, this is a different. Now it calculates the steps. Yeah, this looks exactly like what we wanted to write, right? Let's also remember the wrong answers maybe this time. This one is wrong. So what did Codepilot write? List of points. We have a start point and an end point. Then it looks at the difference between those, then calculates the steps, whether we need to go +1 or -1. Then we start at the start point, and as long as we are not at the end point, we add the current point, then move the steps, and then we add the end point. That is exactly what we want to do. And get points is this function. Yeah, let's run this again. This is now smaller. Let's see if this is the right one. That is the right answer. Okay, we had a bug in this, and I was probably caused by the bot proposing wrong code. And this one now doesn't do the cursing because it can go + or -1, so this is definitely working no matter in which direction we need to go. That is nice, and we solved day 5. I hope to see you in day 6. You can find all the code we just wrote on GitHub, on my GitHub repository for Advent of Code 2021. And yeah, let me know in the comments how you solved this. If you have a better way of doing this than what we did today with the help of GitHub Codepilot. GitHub Codepilot. I don't know why I keep saying code, but I think it would have been a better name. See you tomorrow. Bye bye.